Okay, so this is a wee look at some number systems, notably the binary system. So we need to take a look at how that works. So a number system is what we use to count and how we understand how many we have of something. We count in base 10, which is our usual decimal system. The most notable alternative system is binary. This is used in computing. Binary only uses the digits 0 and 1, and the place values in binary are the powers of 2, just as the place values in decimal are the powers of 10, units, tens, hundreds, thousands. And that's 10 to the power 0. If you will remember, 10 to the power 0 is 1. 10 to the power 1 will give us 10. 10 to the power 2 will give us 100. 10 to the power 3 then give us thousands. And that's what we have then on the table. If instead of powers of 10 we look at powers of 2. 2 to the power 0, because anything to the power 0 is 1. 2 to the power 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64, and 2 to the power 7 is 28. If we want to write a number in binary, we have to consider how to make it up using only the powers of 2. The first step is to find the highest power of 2 that can be included. Writing 14 in binary, the largest power of 2 that could be included is 8. As 16 is too big. 16 is bigger than 14, so that's no good to us, and we work our way down from there. So we don't want the 32 in there. And if you notice, these are the powers of 2 up here. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, and we generally write them the wrong way around. It's just easier than the binary kind of works, actually going from here to here. So writing 14, the largest power of 2 we can include is 8. So we don't include this, so it's a 0, and a 0, and then we have a 1 here, so that's 8. Can we fit in a 4? 8 plus 4 gives us 12. We can. So that then we're up on the 12 now. Then another 2, 13, 14. So given in binary, then 14 is going to be 1, 1, 1, 0. It'll make a bit more sense, hopefully, whenever we can start to do some of the examples here. I hope we can see how we get on. So this one then has 5 numbers in it. So we need to go down from 16. So we're going to have 2 to the power 4, which is 16. 2 to the power 3, which is 8, 2 to the power 2, which is 4, 2 to the power of 1, which is 2, and then 2 to the power 0, which is 1. This is a wee table to help us work out what we're doing. And we're told that the binary here is 1, 1, 0, 1, 0. So that means it's going to be 16 plus 8. There's no 4, but there is a 2. So our binary number then in this particular case must be 26. This next one then has an extra digit on it, so we need to go then a wee bit further. So go to 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So it has a 2 to the power 5, doesn't have any of the next two, 0 and 0, and then it has a 1 here, and a 0 and a 1. So our number then is going to be 2 to the power 5 is 32, doesn't have that, plus 4, plus 1, and so our number then is 37. And just like in decimal, we can express any number, any of our whole numbers in terms of binary. So, in decimal, the number 37 is the number 37 decimal, that's what decimal means. But we can write any number we want in terms of binary just using these powers of 2. We need to be able to do it this way around. We also need to be able to do it backwards. So, we have 76 here. So the way the powers of 2 go up, they go up, if you remember, 1 and then 2, 4, 8, 16, 32, 64, 128. So we don't need to go up as high as 128 because that would be too much. So we just need to go to 64, which is going to be then our 2 to the power 6, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, and 2 to the power 0. If that helps. We can have our numbers here so we know what they are. We have 64, we have 32, we have a 16, 8, 4, 2, and 1. So 64, does that fit into 76? It does indeed, so we need one of those. we're on 64. 64 plus 32 is going to make it too big for us, so that's no good. We have a 64 plus 16, that takes us to 80. That's no good either. We can't have one of those in there, it's not going to fit. 64 plus 8, that does fit. So that's going to take us up to 72. So we're now in 72 and we want to get to 76. So we need a 4. And that should be us. So 76 in binary is 1, 0, 0, 1, 1, 0, 0. Similarly then for 93. Keep those numbers above so we can see them nice and clearly. Again, we don't want to go as high as the next one up, which would be 2 to the power 7. That would be 128. 128 is not going to fit. So 2 to the power 6, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So yes, that one fits. So 64. 64 plus 32 is no good to us because that would take us up to 96. So we don't want one of those. 64 plus 16, yes, that takes us to 80. Can we add an 8 on? That'll take us to 88. Yes. Can we add a 4 on? That will take us to 92. Yes. Can we add a 2 on? That would take us to 94. No. And then we need a 1 here. So 93 in binary will be 1, 0, 1, 1, 1, 0, 1. That's the way we work these out. Again, you can do it for any number, and we need to be able to go forwards and backwards. Apologies for any of those we're trying to work out.